Thanks for everyone for coming today. This is, I think, the 5th beer and BS we've had. You might have noticed that we've sort of split the groups into two just to make it a little bit more of the conversation, just a little bit easier for us to sort of debate, have our 2 bobs worth of information rather than 10, 11 people in the room arguing. So on today, we have Jess Kismet, Building Sciology, Justin O'Connor, PHCP down in Tas, have I got that right? And Performance Membranes, and Dr. Cameron Munro. Always blessed to have the doctor with us. And Drew, who should be joining any minute now. So he's just working out technology for the first time. So today what we're going to go into detail with is I'm actually going to talk about my house. So I'm going to be presenting on some of the details of my house. I know Justin's come through. Cam was part of the design team who helped us achieve Passive House certification, which we were officially last week got the approval to get this across the line. So the plaque should be, once I pay my invoice, it should be in the mail pretty shortly. So that's super proud of that. I know I did claim that it was a Passive House before this, but officially we're across the line. I know Cam's laughing here. And we might go into detail why it's really important to wait till you actually get that plaque on the wall before you call it a Passive House or that certificate. And we'll jump into the end. So Jess, Justin, Cam, jump in wherever. Kind of a really good mix here. We've got Cam and Jess, who all 3 of you are probably actually some of the best building scientists in Australia. Justin's also a builder, so you're going to pick apart my building details. And Cam's probably going to be able to go deeper on the actual numbers side of things. So, I better go back to the start on this one here. So, for any of you that might not have seen, my house is actually also on Grand Designs. So, it was on air late last year. If you haven't watched it, you can definitely watch it on ABC iView. I think it's episode 10 of season 12. So, a bit of a brief on the property. We are building on 190 square meters. And we are building on 3 of the boundaries, and we're doing brick veneer on all 3 boundaries for fire rating. So the nature of the building, because this front from the front coming through this way here is north, we wanted to capture as much north from that side. And what we hated about our outhouse is that the backyard, we had a sort of a north-facing front. The backyard just was always dark and gloomy, and we wanted to sort of work out a way to approach this differently from a design perspective. So we did something odd that most people would consider weird, and we have pushed our backyard to our front as well because we don't have much land. We are on a tight bit of land in a residential setting. So we sort of flipped the script a little bit and sort of thought outside the square on how we could approach that. Now, having lived in here for 4 or 5 months now, I can tell you it's perfectly fine. We're in a quiet street, so there was always the element of security, but we do have about a 1.5 meter high fence. So there's that security from there. We've got security cameras, but it is kind of nice interacting with the street when people do stop and walk past. The neighborhood's quite lovely. So we do have the luxury of that. And I do understand that some people might not like that as a actual design principle, but at the end of the day, the brief to my team was Passive House, which means like we have town planning constraints here, we now have design constraints to optimize that north solar, passive solar design. So what I want to touch on is the slab to start with, because being on a tight site, we opted to use a white polished concrete. So it was white as concrete can get. Now, the issue is that if we went any wider, the oxide would actually start to break down cement and we'd have issues with the concrete. So that was a challenge in itself. And to give context, I think usually about $300-400 a cubic meter for a concrete. This was up around the $1,600 a cubic meter for concrete. So I didn't want to go spending a fortune on my whole concrete slab on white concrete when it's going to be in the ground. So what we decided to do was, and I had to build the place, I had to build a double-story project. So I opted to build a traditional slab, not worry about insulating it whatsoever, and then build everything on top of it. So it gave my team the ability to build a frame, drag a frame around it without worrying about the expensive concrete. They might scratch it, dent it. Also protecting it when the issue that you have when you have polished concrete is when you grind and seal it, then you put a blocker on, you put something to prevent the it getting damaged, you're usually putting on a plastic, and that could become a vapor blocker. So all the moisture can get trapped. And what is really a common thing is you can actually see all the lines from where you've rolled out the material to protect the concrete slab. I don't know, Justin, have you ever had or seen that problem?
I've seen a few issues with covering up slabs with vapor blockers that are polished.
Yeah, so a big tip is use a cardboard with it, and make sure the tape that you're using is vapor permeable, so anything trapped under it can escape. So that was a huge concern. Now, again, didn't have much room to move on the site, and what I decided to do was it needed to be thermally broken, part of the passive house design. So what we opted to do was use a 75mm XPS on top. So I'd build my frame, we'd do all the interlo. I was locked up, windows in, and then just before plaster, we decided to pour the slab. Now, the important part that you need to really, really, really consider when you do these things is airtightness. So biggest thing that we had to do and consider was you can't tape to, if you can see my marking here, I'm drawing in blue here, taping here isn't the option. What you actually have to do is tape down on the bottom from your slab underneath the XPS before you do it, and tape up here, because ultimately I'm relying on this part of the slab to become my airtight barrier along here rather than top one. Now, I'd learned that from the past from other builders who had taped their airtight barrier onto the top of the infill slab, and they had air leakages around the place. So it's a typical problem with chipboard, especially if you don't follow this method with chipboard. You'll find that can seep through the chipboard layers if you put a subfloor on top of this system.
Is that just cracking, Matt, from the slab that creates the air leaks?
I have no idea. I never went that far to understand it. I just knew it was a risk factor, and stupidly opened my mouth wanting to build Australia's most airtight house in Australia. And I'll spoil alert, we ended up at was it 0.23, I think, or 0.24? So quite airtight. So for me, I was looking at every little detail that I could think of that might improve the functionality of the airtightness and slab. So that was a detail that we started with. Now, again, having to have the conversation with our engineers, how do we actually do this? Can we do it? What's going to work? Ultimately, this is something that's been done a lot of the time, more commonly when people are using a hydronic heating system. They will run their pipes on top of the concrete slab and then infill on top. Now, would I do this again if I had a different polished concrete or a floor covering? Probably not. I am noticing that I am getting a lot of cracking within my concrete, but that is normal for polished concrete. The gaps that I'm seeing, I can't put a piece of paper down. They're quite thin, but visibly enough that it does drive me a little bit insane, as I did want a uniform finish. But ultimately, if it was a client, I would have told them that this would have been a problem, that this would happen. But when it's your own house, you're a bit naive that this might not happen to yourself. We opted to use instead of a steel reinforcement in this top layer, so through here, what I did is I used a glass fiber bar rather than steel. There was a higher tensile strength. There was a higher tensile strength in that, and the engineer was happy with that. Plus, we also just didn't want to encourage any thermal bridging from the underside of the slab all the way through.
The question from Joe is, concrete thickness, is this the limit or based on cover, in brackets steel, i.e. topping slab?
So we can see here the engineer specified a 70mm polished concrete slab on top. All right, engineer will specify that. I increased that to 100. I didn't feel 70mm was enough, to be honest with you. Now, the reason why is by the time that you start to overlap certain layers of mesh or the bar, so you might have a, I don't know, SL72, and it might be 7mm or 9mm, 82, depending what we use. I find that double up can actually cause the thickness to increase. And what I didn't want is that coverage not being enough. It's a problem that I've seen before, so I do opt to increase that. Now, how I was able to get away with that, pretty much not doubling it, but adding another 30mm, we were actually able to lower our house into the ground a little bit. We had the ability to drop it 20mm from our RLs on site, and how it all worked out. We worked this out before we hit the site. And then I just added I just lost 10mm of my ceiling height inside. So I think I've got about 2.8 meters inside. So losing 10mm within that space to me was not a problem. I felt that was more valuable compared to running a 70mm slab and potentially grinding a spot in the ceiling and seeing a bit of the glass fiber bar, which shouldn't have happened.
But the glass fiber bar?
Oh, good. I think it's 13mm.
Oh, so it's pretty thick. So when you're doing overlaps,
Yeah.
it's a real risk to get cut. in the slab surface.
Yes, we've used it a few times now. Now, it's no thermal bridging. It's all the data says it's a little bit stronger. But why I thought this was a better option compared to on an infill slab is one person carry through the whole set of bars into the house and lay it, where if you got sheets and mesh and I've got airtightness membranes everywhere, they're going to damage it at some point. And if I've poured a slab and I can't get to it, and they've done it down low, but when they're trying to get their mesh and squeeze it in, I'm in all sorts. So I felt this is the best way to prevent any issues going forward.
Matt,
Other than that,
just a comment on the thermal bridging there, Matt, because that infill slab is completely surrounded by insulation underneath from the XPS and on the side from the glass wall, it doesn't really matter whether it's steel or glass fiber.
I know. Insulation will sit like that.
Just make that comment.
Yeah, and we've more looked at this probably in other slabs and other details where I've got this board pier to connection. I'd actually run that if I can as a glass fiber bar. Sometimes I've had that as a problem where we've looked at using that as a bit of a difference, or if I've got a block work wall is another example where we sort of. I also want to reduce steel in the building as well. It's just one thing I don't like dealing with it from if we can look at other options and try some new things, it's something we look to do. Next slide here. Hopefully all my images clear. So this is a bit of an example. I've realized I've doubled up on this image. So you'll see this is the start of the project. We're tight. I have no room to move on site here. So you can see traditional slab, traditional pour on top, and then it just allowed us to work. So along this boundary was super tight to build a brick wall, and you can kind of see in this section here, there's a spa next door. So we had very, very limited space. Having said that, we did at the back have right away, so that provided an opportunity to sort of access from both sides. All right. And then we just use XPS fill the whole way. We used a non-expanding foam. You can see around these spots through here, just to make sure we're making it as continuous as possible to get the insulation. We can't cut it 100% tight, but it did provide a bit of an option. And what we did is we really increased, and I found that this is where my re-entrant bars, this is where I'm getting a lot of cracking in the house in these sections through here because they're weak spots. If I had my time again, I would have tried to leave out some of the internal walls, but having said that, all of them were load bearing, or like they're pretty much all load bearing. So I didn't really have much of a choice to do anything otherwise. So it's something I thought in my head how could we approach it, but at the end of the day, that's my decision to put the concrete. Now, the other thing that you've got to see and be very mindful of, we put A-Will flex around the whole thing. We did 2 layers to make sure that we were allowing for any expansion to the concrete. Now, we were able to do that because I had a 45 mil cavity for my insulation, where some people might just have plaster going directly to a stud. That we had the ability to add that extra layer around the outside to allow for any expansion in the concrete because it kind of is otherwise gridlocked. That's something to be also mindful if you're pouring a decoupled slab and you're using block work as your means of formwork. Also make sure you're running a 360 A-Will flex around the building just to allow for any expansion. It's something that we nearly got caught out on another project. And as we're about to pour, we realized it. We had to run down to Bunnings and buy 5 or 6 rolls just to make sure we allowed for any movement because, there's nowhere for that concrete to go should it expand. Jess.
Question from Joe. When you say cracking, is it only visual with size?
Yeah, it's only a visual. It's pretty much moving from, say, this wall to this wall or this wall to here and vice versa through things like that. So they're very hairline cracks. They're not structural whatsoever. Probably in a year, once they settle and I go through a full season, I might get someone out just to fill them and buff them. Look, at the moment, they wouldn't be able to get any fill or anything in them to fill them in. And I constantly, every day, run my feet over them to see if it's any lip in it. It's dead flat. So there's no raising from side to side. Justin's laughing. He's a builder. You know what it's like when you're own home. So
I saw them when I was in your house, so I didn't comment on them because
you just know that
I didn't want to say anything. It's like, yeah, I feel pretty bad about that too. It's one of those things, pain point. Don't mention it. Or,
yeah, it's just like it's a decision that we made to have concrete. I can tell you, so most people would usually throw a hydronic heating system through here. Look, it's been summer. I can tell you that it's so comfortable to walk on. I'm actually really excited for the first time they head into winter. I really want to see how this slab holds up because it's felt different to anything else I've experienced before. And what we've got to remember when we talk about floor coverings, it's the only surface that you're constantly in touch with. You don't sit up with your hands up again and lay your whole body against a wall but constantly in your house, you're walking on the floor. So you do want that surface area to be something that's nice and it's not soft, but warm on your feet. Even when I've just been playing around with my underfloor heating in the ensuite downstairs. I've just been testing it. Once it heats up, it's probably until it gets about 25 degrees I can actually start to really feel the difference in the two materials. So I would say roughly it might be sitting at around 23-ish degrees. That's what I've started to notice it. What else we got here? So just key takeaways for slabs: tape your interlock down to your structural slab, able to flex around all the internal external walls. So run your PHPP, find out what XPS you need. Is it 50 mil, 75, 100? It all is depending on your climate. Model early, model often, as Cam would always say. And the install rate is exactly the same, whether you're installing a 50 mil or 100 mil. Nothing should change whatsoever. It took one of my boys pretty much a day to install all downstairs by himself. So it wasn't actually a long time to do it. It is really efficient doing it this way. It's just that it's probably a different way of doing it. I have a Festal insulation saw, which cut the XPS, which made things a lot easier compared to a power saw or a hand saw. So he was able to set up the guide and just run it very, very quickly. It's not yet of doing it. I probably, if I had an option to do this differently, I would. But given the floor covering we chose, I didn't have another option. The other thing is also, before you set up that further bottom for your plaster at a height that is above your finished floor level, just so you're not having to do things twice, or a piece of timber gets caught in the way and you're 45 mil short. You can't cover that space. Cam, do you have any comments that you want to make on the slab from a thermal perspective?
Just trying to remember. No, we did test different insulation thicknesses, didn't we?
100 mil, and when we decided to go to the triple glaze clad windows, we were able to get it back down to 75 mil.
Yeah, and then that comes back to my model early, model often point. Use it as a thing to do trade-offs when you're in that initial design stage. So we would have said, hopefully would have said to you, right, if you double glaze it, you'll get this. If you triple glaze it, you'll get that. If you go for 50 mil XPS, you'll get this. If you go for 100 mil XPS under the slab, you'll get that. And then it's over to the builder to work out which is the lowest cost option.
Yeah, and as you hit 50, 75, 100, the cost per mil is the same. Like it's not like 100 is cheaper than 50, or like it's the same price per thickness. So how that changes coming up, considering that XPS is a petroleum-based product, and given where we are right now in the world, is that maybe something that goes up in price? Most likely. So we might look at other options going forward, whether that's in subfloor with some bats within it. But XPS currently is really the only option to do something like this, unless you guys have seen or tried anything else. You don't like the detail?
No, there's been a few things. Clinker and the glass beads.
Foam
glass that was tried a few times in Tas out of the mining industry, but it's all pretty expensive. You just can't get anywhere near the price point of foam, and it's a pretty poor product, but it's long.
So another thing, if I go back on the poor product, what we actually did is, you'll see here, I've got my XPS. We put our plastic on top of it. So in the future, should we ever want to demolish the building, this XPS hypothetically should come up and be clean. It shouldn't be attached to concrete. So we try to think ahead of the time, and in maybe 200 years when they decide to recycle it, and most likely by then there's an efficient way, or the world's no longer here. But we at least have an option. We kind of thought ahead for the future people living in the home.
Is that to try and stop some of the slurry draining down the cracks as well?
No. It was also so we could wrap the plastic up past pretty high on the walls, so we weren't getting splatter from the. I think we cut it after. This is a few days after, but we cut it. We were running it up to like here, just so nothing was getting damaged in the way. And if there was a hole in the black plastic, we could also check the interlock. So that's concrete slabs. Framing. So what we opted to do was 600 center framing. I wanted to design out all the steel. Now, granted, I have a steel beam out the front here, but that's for architectural reasons, and that's completely outside the thermal envelope. I also, given that I was working on 3 boundaries, I was like, well, how am I going to wrap this nice and airtight? So one of the things that I decided to do, I'm really big on wrapping a whole house in ply. I think that it adds a huge amount of structural stability to the house. And one thing I've noticed building passive houses is, and this is a common thing that I found with some of the other builders like Hamish and Brad and stuff, that where my corner of my joins of my skirting or my architraves, I've just noticed they split a little bit more. They're just a little bit more noticeable. So I don't know whether there's more movement or something like that. So my decision was to wrap the whole house in ply, and I haven't had any movement whatsoever at all. So it has been literally dead. Nothing's moved. So that allowed me to do a peel and stick membrane. Now, peel and stick membrane's probably a little bit more superior to a standard membrane. On it, like we're looking at like 1% improved. I've got 3 people who know membranes pretty well. My understanding is that there is the chance potentially of a membrane on the backside condensating on a ply if it's not peel and stick. If there's a little bit of a gap or you haven't installed it 100% tight. And given that we won't be able to access 360 of the building, I just thought we can build all the frames on the ground level, fully adhere it, and then stand it up. And then we were already watertight from the moment that we were starting to build. So it was like a bit of a cassette system. Now, the other thing we started to do was completely design out all the steel. So through these sections through here, I have some big glulam beams, like really big, thick glulam beams. Now, I underestimated how heavy a glulam beam is. We had to pretty much we had to get 2 duct lifts to lift them up. They were just as heavy as steel. We all thought we were going to be able to lift them up by hand, but they were 360 high by 140 mil wide. Yeah, they're damn heavy. So that sort of threw us out a little bit. Now, balloon framing, I'm going to go into that in a second. I think it's really important. It's a way that I wanted to construct the upstairs to downstairs airtightness. So the other reason I used Hero completely externally was I wanted to just make sure that we were getting as airtight as possible. There's some tricky junctions in this house, and whilst we're pretty good at wrapping a house internally with Intello, I just thought that given that if we wrapped it from an external point of view, we could sort of really control that airtightness level. You can see here, built them on the ground, completely plied. Opted to use a ply off the shelf. Now, that could be debatable, and I know Cam's going to go into that in the future. I didn't use an OSB 3 ply on the walls. On the roof, I did. I just, from my understanding in my guesswork, and I shouldn't guess, that I thought this would be as vapor open as it would an OSB 3 ply.
What thickness is that?
Good question for the memory. Maybe 12 mil, I'm going to guess. You worried?
Not at all.
No. And the other thing and I don't want to steal Cam's presentation in the future, but I thought with plywood, you got 3 layers. Like with a standard ply, you got 3 layers compared to the OSB. It's just chipboard everywhere, pretty much. And what I've read up in the US, what it can be a common problem is if the plywood gets wet, it stays in one of the layers of the ply and it runs vertically, so it dries quicker. Where if the OSB gets wet, it can actually spread throughout the whole board and rot at a faster rate compared to the standard ply. Are you guys come across that or seen anything like
that? I've seen some OSB look a bit average when it's been in the weather for a prolonged period. Gets a bit splintery.
It's probably all ply though,
I've
isn't it?
seen that with ply as well. Like
yeah.
I mean, the ply laminates can delaminate pretty easily if they get very wet too. I would have inferred it a little differently, Matt, that one of the advantages in my view of the plywood is you've got a veneer of real timber. And so if you get a spot of water on that timber, then it can permeate along the grain direction. And that gives it more surface area and therefore it can evaporate off again more quickly. Whereas with OSB, you've got a strand or a bit of wood stuck in a sea of glue and it can't distribute out as well. So one argument is that the ply can dry itself quicker should it get wet.
That's what I was trying to explain. You just explained it a lot clearer and better than I do.
But I think the bigger point here is probably to emphasise the role of Intello in this system. You've got a relatively, a vapor retarder assembly essentially on the exterior of your build, the ply and OSB, and then the Adhero.
Yeah.
And by having the Intello on the inside, you're controlling the rate at which vapor can diffuse through that wall and accumulate on the backside of the ply. So that's doing a lot of the heavy lifting and protecting this assembly.
Yeah, and I went a pretty sometimes like simple shit works, and that's why I stuck with a 140 mil wall. We can on the far right image, just typical detail we have in nearly every job. So in here, insulate the cavity because it's just a really efficient way to you've got a high amount of surface area on a build, and for a few $1,000s, I find that it really can improve you can really lower your kilowatt hours very, very quickly for a very cheap cost. Like I think it's about $3, let's just call it $4 a square meter to supply that 50 mil polyester cavity insulation. And then takes two people 2 days to install because it comes in rolls. I've also noticed that because it's a little bit denser, it also really, really helps with the sound. So when we talk about comfort, yeah, it adds the thermal comfort, but the sound, like apparently it's raining outside because I opened a window just to see what was happening. And I had no idea because the sound in here is just, the acoustics are great. And you'll just see here on this image here, it's just a standard image that we have that for most projects, just 140 mil through here. Now, again, depending on your climate zone, if you're in New South Wales and above, you might get away with a 90 mil. Just be careful if you don't have in tallow. There can be the risk of condensation to some degree, from my understanding. So, but in Victoria, we pretty much won 140 mil all the way. Outside, you can see the ply through here, vertical batten, cavity batten cladding in this space through here, and importantly, the window and where it's located. So all our windows, which we'll get to in the next stage, all located within this the thermal layer. You can see the glass is within this layer here. What else we got here in the framing? So you'll see here, we can see it's all completely, adhero wrap it all the way into the frame to protect it. That's my team having to stand these walls. And you can see we've actually run the ply higher than the top plate because in here are my rafters. And so when we had that rafter detail coming on the angle down through here, and I've got my wall, so I'm not going to draw a bird's mouth. You can see here, this ply sheet was already running up to the back side of the rafter. So when they did the top one, it just ran down it again. So when that adhero line would come down, it was just continuous. So it's a very bad image, very bad sketch. Now, the thing I did notice with the adhero that was apparently quite normal, we did find it bubbled a lot and then it would go back to its shape. Like, especially when it was sun, you'd see it was sort of delaminated from the ply. And then the next day you'd go find it, it was completely stuck again. And we saw, I don't know if you guys have experienced that or seen that before.
I've seen moisture make it bubble. So
yeah, there was no moisture. We cut one open. Yeah, Dan said it was quite normal. I don't know why. We actually, you can see here, we actually, we used the primer between each joint as well. So we doubled up on that. We didn't just rely on the adhesion of the adhero to adhero. We actually used a primer between. And then when we butt two pieces of, cassettes together, we just taped them with the Explorer and off we went.
Matt, is it possible the ply got wet at some point before you whacked the adhero on it?
Yeah, so there was a bit of rain. But what we did is we left it to dry for a few days, and it was like summer, so like it was bone dry. So it wasn't like we had 1 day of rain, and then it just what we did is we waited till it completely all dried up, and then we did it because what we worked out very, very quickly, the adhero does not stick if it's wet, even if it's the slightest bit wet, it would not stick to the ply. I think my team got the moisture reader out because they were pretty much running off a number for memory because they knew once it was under a number, it just wouldn't stick. It would just peel off. So it wasn't actually to test the moisture from what we would usually use a moisture reader for. It was just like, are we just wasting our time today trying to get this on? Luckily, we framed in summer, so the ply sheets really, really dried out, and we had them completely. If I go back an image here, this is probably it, where we literally just had all our walls like this, just out in the sun drying for a few days. What else we got here? These are two details that we came up with on site. What I was concerned about is this vertical wall in the second story to a flat roof. All we did is we cut a triangle shape like this out of timber. So any water that would hit this would just be able to continue its path and continue down. What we had noticed in the past, I don't know why that does that. I got it better. We just noticed that it got stuck in that real tight join in the corner. So one thing we'd come up with on this job, and I wanted to try it, was we just cut a timber on the angle, whacked it in, shot it off, and then did an adhero and then taped over it. Yeah, there was a bit of a positive lap on our adhero, but it was what's it called? We primed it, we doubled up the adhero, and then put a layer of tape on to make sure nothing got on. So Any questions on that? Jess, you got your hand up. Jess? No. Jess, just jump in if you got any questions.
Oh, sorry, my microphone wasn't on. I was talking. There was just a question about the permeability of OSB versus ply. Cam has put an answer in the chat, though. It's a question that comes up constantly, and we never really seem to get a straight answer. So I'm typing something myself as well.
Well, what's going to be interesting around that is, and we kind of had a bit of a chat before we started, and spoiler alert for Cams, but also for we were recording a podcast with Villy from Pro Climber yesterday, and what he was saying that ply is now part of the control layer of the building. So anything that your membrane is or touching is a control layer, and it needs to meet the vapor permeability of whatever the membrane is, from my understanding. So there's no.
Has the final draft of 2025 been released?
Well, I think so. Yeah,
that was in the draft, but have they actually produced the final document? I didn't think they had produced the final document, so that we don't know what is that. Have you seen it, Cam? Have you seen it, Matt?
No, they never changed the draft. They very rarely change something from the last draft to the final, do they?
They were getting immense pressure from lobby groups, especially about cavity on walls, to have it removed. Obviously, won't go into who the lobby groups are, but obviously
still the steel industry.
It was in the draft that the control layer, the brace ply, etc. Essentially, we probably have to move it to the inside to comply, which then has sequencing issues because it's not permeable. I've been trying to find more permeable boards. Obviously, plywood.
Oh, it's B4, wouldn't you?
Plywood, no, it's tighter.
Okay.
Plywood might be, but it's not tested, so we don't really know. But I have found some products that are 2 to 3 times more permeable than the current OSBs that we see on the market. They're still not class 4 though.
Yeah, wow.
So we might need to go to, I don't know, like gypsum, exterior grade gypsum, cement boards for those sorts of, I don't know. But we'll need to solve that.
Yeah, because like the issue, what's going to happen is, well, what if the engineer doesn't spec the right vapor permeable board when they put bracing on? Are they liable?
Well, the building surveyor needs to give the likely compliance, but at the end of the day, it's up to the builder.
So a Hero on a wall would then no longer work.
The Hero's class 4.
Yeah, but the ply that you'd stick it to.
Yeah, correct.
Not
as good as what it's sitting on.
Yeah. So would the OSB 3, that wouldn't be a viable option then?
That's not class 4.
Yeah, interesting. And it comes back to the pressure we've got to put on these ply manufacturers to actually go and get it tested.
Yeah, we're a pretty small market. That's the problem.
But ultimately, they could also be liable.
Well, it's going to have to be solved, that's for sure. But I guess they'll find a solution when the stick approach is there. They'll have to find a solution because it'll be non-compliant otherwise.
Yeah, I haven't seen the final draft, so it's going to be really interesting to see what happens. Now, I'll keep going because I've got this detail here on the right. All right. So it was an upstairs to downstairs roof to wall junction that I was really concerned about, and how I was going to vent that roof sheet considering it was a flat roof at like 5 degrees, but also allow any condensation to move down. So we came up with this sketch here. So what we did here is we use those, and look, be mindful the cavity closures were not out at this time. That would now also solve the problem. But what we did is we got the VB battens from, I forget who sold them, but they're 20 mil. They're essentially plastic strips that have got a huge amount of aperture to allow air to continue to move up and around, but also water to drain down through here. All right. Now I'm going to see if I can remove from this image. Here we go. So I want to go, if I go skinny, it'd be nice. So what we did is we did 2 layers because having one wasn't going to solve the problem, because if I had one and I didn't have something at the bottom for my top layer for my counter batten, something hypothetically could crawl up through here because I would have had 20 mil gaps. So they're both serving different types of purposes. This one here is to allow this to come up through here, but also moisture to drain down. It provides a nice backing for my flashing to sit against. So it's nice and watertight from that capping flashing that we'd have on top. The soaker is probably the more technical name that I'm after. And then this top one here is to close off this top layer for this second story, but still allow enough ventilation to get through here and get down. So that was, given what we had at the time, a detail that we were pretty happy with, because it was something that we were a little bit concerned about on how we would approach that detail. and also have enough airflow from that flat roof. Because a lot of time what we see is that roof sheet will just shut off at the end of the wall and it doesn't go anywhere. So there's no ventilation through that roof sheet through there. Just good to know as well that if you are doing that flat roof, you do need a 50 mil cavity batten, anything under 5 degrees. Is that right, Justin?
That's what the DIN standard recommends as a minimum.
Yeah.
The install guide of ProClima's, the Hero flat roof says 45.
Yeah, okay. So yeah, go with 50. If the standard's 50, just it's an extra
We always
5 mil.
go 50. Yeah.
Yep. And really important to use the Nadic tape on the underside of your battens because it is double-sided, and being a flat roof, you want to make sure every penetration is really, really sealed. Even when we've seen it rainy, just the water moves off really, really slowly. You do want to make sure the water will sit there for a while before it moves. Now, granted, you're most likely not going to have that amount of rain, the amount of water compared to a thunderstorm, but hey, it's a great way to test if it's working or not. You guys have any questions on these details?
Yeah, I guess the inlet and outlets need to be as per the table in the NC.
Yeah, but I'd have enough through here. I've got a huge amount of ventilation at the bottom, like massive amount of ventilation coming in and out. And that ventilation goes all the way along. So it's no different to what you have your cavity batten now that we can get from you guys, Justin, at Performance Membranes. It's just it's a thick one.
I think designers need to take screenshots of that, Matt, because I never see those detailed on a plan. It's just as per 10.83 in the NCC, and the builder has to work it out.
Yeah, so really interesting podcast from Steve Basic from the Build Show. And I've been talking about this a lot recently. He said his architects always ask him, what's some advice? He's like, draw the hard details. Don't sit there and draw the slab connection to the bottom plate. Everyone knows how that works, or the joist to the bearer. We've all worked that one out. Go draw the detail that you don't want to draw, because that's the detail that as builders they need. This took me, my construction manager, my lead on site, and the roofer. We probably spent 3 hours detailing this so it would work, because we wanted to make sure that everyone was having their say, because the roofer like, well, I need this to fix this to comply, but we would also want something for airflow, and then we'd work out a calculation and what would also look good. So they're just some things that you need to consider. But as an architect, even if you get it wrong, ask the builder, because we can help you, but at least you're trying to solve the problem rather than go, that's your problem on site. Because if you don't draw it and we need to do this, technically we can go issue a variation. All right, balloon framing. This is a fun one. Now, what we've done in the past, this is a side detail here that we sketched up. So typically you would have a top plate through here, and you just see your joist or something run on top like this. And then what you would usually then see from that is the airtight membrane. How do you get this airtight? So everyone would then, go backwards. I don't know what I've done here. What people would then do is run the damn it, what's not happening? So then what they would do is they'd run their airtight barrier like this, and then connect it to the upstairs. And then on the outside, what you'd have is a new external membrane like that. Now, I think it was you, Cam, that discovered this. There is a slight chance that there is condensation that can occur between here because there's no insulation. Was that you that discovered that, Cameron?
I don't think I discovered it, Matt, but I suggested it's theoretically plausible, because you're putting your vapor retarder, which is, say, something like a ProClima Connex strip, on the cold side of the assembly in that detail. Whereas in a heating-dominated climate like ours in Melbourne or Justin in Tassie, you normally want to put that vapor retarder on the interior face, on the warm side of the assembly, so above the dew point temperature.
And ProClima removed this as a detail originally. They actually had this as an original detail, but they removed it because they thought, this could actually be a problem. So
the original detail actually, like a long time ago, had that connection strip retracted back in at least 50 mil back in from the outside of the wall frame, but somehow that got changed, and it could be a problem.
Yeah, so what we did, balloon framing, we just ran our starter strip down through here. We can attach this to the wall. Then what you'll see here, if I can change color, we actually here put this a little bit different. We had a bit of a cavity batten through there, and then we installed a whaling plate. And this is all designed in the engineering. We had this conversation early through here. So then our joist could actually sit, this is a different cross section, could actually sit on top like this, like that, our posies. So this purple line is continuous. It's not getting damaged. Also, the issue is when the other way you used to do it, you chuck the joist on, it could rip it. You wouldn't have any clue if you're ripping it, moving joists around on it. This way it stays nice and clean. It's pinned out the way. And then this allows one, if you need to get something from upstairs to downstairs, you could be in a bit of a pickle. It allows you to kind of chase something through here if you needed to, but it also meant that we're completely continuous all the way through in a straight line. Didn't complicate the framing. Now you can see here, this is what we kind of did here on this image here, wrapped around the beam, a bit of a cavity to allow stuff to get down there if we needed to feed the cable or something. And then up here, you can see on these chipboard that it's folding up after we fold it, and that just ran now straight up the wall as a connect strip. Then in the future, all you need to do is run your Intallo membrane. Just simplifies the Intallo install again. You just run Intallo over like that, and then you just tape the join where you join. A much easier, slimline process. Didn't complicate anything. It was something that was not drawn by the architect. We had the conversation with the engineer. It was in our heads. From now on, we'd ask that to be detailed, but we just found that as a more efficient way to do things. Any questions on that?
Also just helps you get that insulation all nice and continuous through that detail.
Yeah, and this isn't sort of drawn right, this detail here. We actually sat this other plate up a bit higher, up through here. So we actually ran that downstairs well a bit higher. So we knew that, because this means this is just more continuous all the way through, all the way, made it easier to access the insulation. We could feed it up from the outside and feed it through the studs rather than we're kind of gridlocked. And usually that other method was not really that thermal efficient. What have I got here next? Cavity insulation, again, it is a super cost-effective way to do things. Now, biggest tip I can give to anyone that runs cavity insulation, 45mm battens, don't skimp out on the 35mm battens. The reason why is this stuff comes as 50mm and it slightly gets compressed, which is fine because Cam knew that. But what we found when people have ran 35mm, or when we ran 35mm the first time, it was really pushing some pressure against our plaster sheets. Now, it was fine and we got away with it, but I wouldn't have wanted it any thinner because I was concerned that we wouldn't have been able to get our plaster sheets on. So that's just something to be really, really mindful. It's one of the most efficient, easy ways to get insulation into the insulation of the building. But you can see through here, like we're literally going through every aspect. Just because our ceiling line stopped around here doesn't mean that we don't insulate this space here, because that is still considered our wall.
Just a couple, certainly for anyone in Victoria that's looking at sourcing a wall surface cavity insulation, you've got polyester options like what Matt's showing here, and there's a Mob polyester solutions that flogs this stuff, and they sell it in different densities. So you can get it in a 14 kilo density, which I think is what you used, isn't it?
Yes.
And then there's also a super high density 32 kilo stuff that's got a slightly better R value, but that absolutely must stay at 50mm. You just can't compress that.
Oh no, yeah, there's no chance. Yeah, you've got no chance at all.
And there's also a couple of options in the Knauf Earthwool range. There's a low density stuff that again is 12, 14 kilo, but that's really light and fluffy, and I wouldn't trust that won't just sag down over time. But there's also a 30 kilo glass wool option from Knauf as well, and that's, I imagine, possibly available nationwide, that I reckon might be a good option for these details going forward.
Now, the only reason I don't like a glass wool in this cavity is because that glass wool can get into the air, and anyone that's worked with glass wool, does not fun to breathe in. Like, whilst we might be airtight, we still have power points and there might be an opening somewhere. So I just don't like putting glass wool if I can avoid it on the inside. And at the end of the day, this is actually recycled PET bottles, so it's hydrophobic. Not that we should be getting any moisture through there, but it's something that I optionally choose from a health perspective more than a energy efficiency. I just don't want to risk glass fibers getting around. Especially the reason why, if you got air cons as well, and I don't know if Drew or you on this call or you can hear anything, but you don't want that return air sucking in the glass fibers and taking that to your air con. So you might as well use something like this just as a safety precaution as well. Windows, the fun one. This is probably my favorite. We might get stuck on this for a little while. So we used Aluclad windows. Logic House, I'm going to give them a massive shout out. Harley and Jason, fantastic. If you're an architect listening to this, these are Harley's details. He'll help you and he'll draw the details for the windows for you. You don't have to sit there and overcomplicate it yourself because, yeah, they can be quite complex. This is the first time we actually ran this. We'd used Logic House windows before. We used to use the Contaga Exo. Is that the window tape, Justin?
The external tape?
Oh,
Yes.
yeah, it's a window tape. We used to use it on the inside and out. Now,
Contaga IQ was the internal one, and
Yeah.
Exo was external.
yeah, I used to use both, the internal for both. Now, good product, awesome product, really good with UP, but you need this detail on a UP, that you need that product on a UPVC window. There's no option. Now, what we did here is we thought, how can we actually do this better? And Harley, I can't take credit for coming up from 90% of this. Harley did this on his own house, but we decided to improve on it a little bit. So windows come. I'm going to go forward to go back a little bit too. So you can see the window outline through here. What we did is all the windows come on site. And the first thing we did is we knew we had a plaster reveal detail. There's no architraves on this. So what you'll see that we did here, you see this middle image here, is we ran a continuous bead of a polyurethane membrane around the whole window. We put I think it was a 2 mil packer, which you can see behind it. And that is to allow the easy reveal to slip in the future. So you can see there's a slight gap through, and you can see actually in image 1 here, that slips in the future through here, down through there. Now, what we then did, you can see this bit through here. This actually was just a bit of door jamb, pine, like dressed all around pine. And what it allowed to do is it allowed us to create a reveal that also allowed us to really neatly run that easy reveal and slip it in between this gap here. Now, the issue that I've had in the past, if you're running easy reveal and you haven't got solid backing, you can get like, I shouldn't call oil canning, but it can be a bit wobbly, and it just gives our plaster a nice substrate to work to. All you need to do in the future is just give it a nice little cork through that gap there, and it comes out really neatly. What it also does is allows us to fix in everything really, really well. It gives us a fixing point because we've got some nice like Aluclad windows. I don't want to be screwing through the back through here like you might see in some other windows and start to ruin what I have. So this allows us, this material, this purple bit here allows us to fix into our studs here like this. But then it also allows us to come from the back end into the back of the window here. So we're kind of fixing from 2 points and getting it really, really nice and strong. All right. So what we did, we ran that. It then allowed us to have, you can see our internal membrane, but it also allowed us to insulate in this cavity through here. When we need it, we'd be just closed spell spray foam. I think we use the Ilbrook stuff. It's really important that you use the right spray foam through there. And then what you can do is, and we had this block here. Now this block is really important because again, it allowed this easy reveal through here to have a solid fixing, and then they could trowel this into our plasterboard. All right. So a bit of back and forth on the side details. We had some corner to corner windows. So yeah, the details changed. But anyone that has worked with Logic House, what you'll realize is they go through every single window and how you're going to install it and have that conversation before it's on site. Did you do something similar with your house, Cam, when you used this?
No, because I had an exterior insulation, remember, and a single membrane system. So we went into we tacked essentially where you've got the dash blue line there for your adhero.
Yeah.
And then it's sealed onto the face of the frame under the Aluclad.
Yeah.
That was our Airtightness connection.
Yeah. So what it allowed us for watertight to do is we had our adhero. You can see, well, it won't let me click this button. You can see our adhero through here. What it allowed us to do is it allowed us to get a bit of Extora tape now and just tape this section from the window to our internal membrane. This means we also can see our red line, which is our airtight layer. We ran our Intello to about here, just before that piece of timber that we talked about before through here. And then we could just put a bit of Extora tape like that again, and now we're completely airtight because of silicon through here, and it's polyurethane. There was nowhere for air to get through on these details. Now, we actually got a fan. So rather than blow a door test, I think Drew, he's not here, we actually used a inline fan and pushed a huge amount of cubic air through the building to a point where I had these things whistling with air, like it was something like simulating 200 kilometer hour winds. I had the windows whistling. That's how much pressure we're putting against the building, and you could hardly feel any air coming through. So we tested an unrealistic simulation of what would happen on that air tightness, and that completely worked. And I'll get down to hosing down the windows in a second. Now, what was really cool, and I'd stolen this from Mark from MVH. He saw this on one of his projects. The Logic House windows actually can get a sill made, which is this detail here. Now, it comes as part of the package. If you ask for it, you got to pay for it. What I found is a common issue on a lot of houses is how do you get that sill looking good? And the metal that we get here that you get prefabricated comes up a little bit yuck, and you got to fold it and bend it on the corners and silicone it to make sure that pan is nice and watertight. So what we did, they have a special system which we can see here on the right-hand image here, which I'll get to, just clips into the window. Probably saved us. Each window was usually taking us, we probably get back in the day 2 windows done in a day. We had all these windows done in about 2 hours. They just literally clipped in and sat in. I'll get to the water drainage at the bottom. So highly, highly recommend. They just got a problem for everything in Europe, a solution for everything in Europe. And that's something that we did to really improve the water shedding. Now, I also sat this past, I think 20 or 30 mil past my cladding. So if we go back to this image here, what you'll typically see is when people just put their flashing hard down, we wanted to sit this out past 20 mil. So the water was not dripping onto the cladding. It was actually just dripping away from the building. And that's something that I think in Europe, it's actually a code that it's minimum 70 mil extends past the cladding. But here we just hug our cladding, and I just decided to push that a little bit further out. So it looked beautiful, and honestly, no one's ever really noticed it, but it just allows the water to shed really neatly away from the building. Now, bottom sill detail, typical detail, we just use the back down, which you can kind of see in that little bit section. Why is my pen not working on this? So we use a back dam, the extra seal tape. Now, big tip for anyone who hasn't used this before, which you haven't captured in this one here, make sure that you tape across on the angle with some Explorer to hold that angle in. And we've just noticed that sometimes it can peel off or peel up a little bit. One thing we also did on these windows, we actually tilted the sill. So when we framed it, the sill was actually tilted on an angle. We didn't cut it like that, but it just allowed, and we sat it up on some angled package, so it sat level. What we found is that, so these windows actually, we had a leak in one of the windows in the bottom of the wrap. What I did is we ran a really unrealistic amount of water on these windows with the hose, and we found one of them was leaking. So what we actually were seeing is how valuable that slope was, because that water just couldn't make it back up that slope. It's something that we actually thought was a waste of time until we found the leak, and it's now become standard practice in our projects because we just saw that it's that extra defense. Like, it's literally like pushing shit uphill. It's not that easy. Even though we've got the back down, we've got the taped on the inside and the outside. Now, when we say taped on the outside, people might say to leave that cavity open to allow it to drain. Don't insulate it. My theory on that is the amount of water that was getting in there was very, very, very little on an unrealistic amount of water that would never hit that window, and it would most likely never get that water in, but it would evaporate in there. I know, Cam, we both had a discussion for a few days back and forth on whether I should insulate in that bottom sill of the window through these spots here. Ultimately, I decided to, because I'm in a pretty closed environment in the inner city. I'm not going to cop that harsh weather, that harsh rain and wind-driven rain, because I'm sheltered from other buildings. But we made it it's really important to use a closed cell spray foam that's not going to wick in that water. I think you taught me that, Justin. I think you did something once where you had an open cell frame foam and it sucked in all the water.
Yeah, it was on a shed. It wasn't.
Yeah,
but it flooded my workshop. I couldn't work out what. I went around the trim deck corrugations and filled them all up with, I don't know, a sticker boom or something like that. And my shed was absolutely flooded, and I couldn't work out why. It was, sucking the water coming down the sheets and bringing it inside. So definitely need to use closed cell foam. Otherwise, it's a big sponge.
Yeah, and we use. I know it's the Ilbrook have one. I think Soodle have one from memory. Yeah, they're the two that we've sort of worked with in the past. Insulating, Cam, do you have any comments on insulating? Why? And Jess, you both do passive houses and model it. I'm assuming there's some thermal bridge potential if we don't insulate it.
I think my only comment is, I think when you've got a back down and a sloping sill, you might be going a little bit overboard there, Matt. But I suppose Rolls-Royce on Rolls-Royce. I think the only other thought I had, we described that too, is when you run that dressed pine all the way around to give you that reveal, like it definitely makes it easy to install. I don't dispute that. But it is actually affecting the side install, the thermal bridge at the perimeter of the wall, because it's just that little bit much more surface area of the wall that doesn't have insulation in it. It's relatively modest, and on most passive house projects, it might have no meaningful impact, but in a project right on the margin, it could.
Well, we were on the margin at that stage. We thought we were. Yeah, we ended up ultimately decided to insulate it. I think Cam put it really well. If you're on top of the mountain and there was no coverage around it, you'd probably leave it undone. But in this case here, we're pretty well protected, and it just improved probably slightly somewhere along the line to decrease that thermal bridge and improve the efficiency within that. But from a window perspective, now lived in this house, I can't tell you how good these windows are. Honestly, like they're insane. So I highly recommend them to anyone. And eventually I'll put something out there with all the products we used, any of the systems we used. So I'll sort of document that out there. Mechanical ventilation. Good friend Drew installed this. Now, spewing that he couldn't make his internet work on this one. I had a bit of a space up in my attic, and I decided to make it a bit of a mechanical ventilation room and install it in there. Work with the Zender products, Q350. The guys at Fantech can't speak. Joel and Nick were awesome helping me detail this. But what we decided to do, because I am in one of the worst suburbs of air quality in Australia, we installed this. I don't even know what it actually is because Drew didn't really give me much of an option. But essentially, it's a 16-stage carbon filter from my understanding. It's full HEPA grade, pretty much in complete control of my air quality inside. Talking about air quality, I'm monitoring it inside and outside. Actually, Cam, my Kia one caught fire on the weekend outside. It's dead. Yeah, the USB part that was plugging the cable into it caught fire and it was all black. So it's in the bin.
Could you bought the cable from Timo?
No, it's the same cable that come with the.
Okay. IKEA quality at its best. They should stick to bookshelves. Fair enough.
Yeah, it was outside, so I've got to get a sensor for outside. It's the P2.5 somehow. But I've been sick for about 6-7 weeks. I've had some form of lung infection. I don't know. Practically, doctor said it's going to be 30 weeks before your cough goes away. And what's really, really challenging is because come Friday, I've been working at home Friday, I'm there Saturday, Sunday, and I'm like, I'm all better. I'm all good. Go to work on the Monday. Can't stop coughing again. So the air quality that I have inside my house is allowing my lungs to relax it so much. You do notice a difference. I was away in Sydney yesterday and had to take antihistamine. I've only had to take an antihistamine twice since being in this house just because someone was cutting the grass when I was walking the dog. So it actually hasn't had anything to do with the house. But regardless of that, mechanical ventilation room, we made enough space for this in the house. We actually treated the machine with respect, because I think a lot of the time what happens is people don't allow enough room to install these. So we gave it a dedicated space. It's not in the room. It's a storage room. Ultimately, it stores luggage and Christmas stuff and who knows what in the future. But it's out the way. Now, I've gone through and I've vacuumed the filters twice already. They can be pretty black already. I've probably only got about a month or two left on them before I need to change my original filters in the Zender. But in this fancy Swiss, whatever Drew's got me, they are dead clean. They are not black whatsoever. There's not even like a speck of black on them, Cam. So when you said that I was going to be needing to changing them every few months, they are perfect. I think if you're in, this is not needed for most houses. I think if you were living right near a freeway, if you were in a very poor air quality suburb, I would suggest you put it in. The cost on that, what value you put on your house. For me, I valued that in the house, and it's something that I really, really thought that was important. It's something I'd rather forgo a piece of hallway joinery and put that in. I can always I could probably potentially retrofit this in the future. It's a lot easier to install now. Now, it wasn't light. I think it was about 30 kilos. So getting it up there wasn't the easiest.
Matt, just to jump in there. So firstly, being Swiss, you haven't actually got pricing yet on a filter replacement, as I keep pointing out to you, reminding you. So that'll come cheap, I'm sure. If someone is thinking about a secondary filtration on their HRV like this, though, it's important to think about the sequence in which you do it. So the way that this system is working is you're drawing in air from outside. It's going through the HRV, which has got an F7 filter on it, which is fine grade, but not HEPA type level. And then after that, before that air is now put into the house, it's then running through your fancy Swiss box, which is then running the HEPA filtration. So a secondary ultra-fine filter. And by doing it in that sequence, your cheaper filter, the F7 grade one, gets gunked up more quickly, and you're protecting the ultra-fine expensive filter from all of that coarser material that's been taken out by the first stage extraction.
Would there also be a reason for it being on the other side for pressure drop or anything like that?
Yeah, so it is adding pressure drop, but the advantage of the Zender Q is that it's auto managing that, like it's changing the fan speeds accordingly. And the reason that Swiss box is so massive is because of these pleated filters. There's a huge surface area of filters in that box. And because of that large surface area, the pressure drop is reduced.
Yeah, interesting. If anyone knows Drew, sometimes just don't argue with him. Just not worth your time. Just listen to him. So it's the reason why we decided to put that in the house. I think last slide. This is just some temperature. Doesn't work. This is on. It was a few 45-degree days at the start of the year. What we can see here was at the 7th of January and around the 9th of January. All I was doing was running the upstairs aircon on the lowest fan speed and downstairs on the lowest fan speed on 23 degrees. So it would only kick on when we needed to. So you can see here massive temperature spikes and then how at different parts of our building, you can see the attic there was always the highest, how it actually performed. So just really, really interesting there. This is not an abnormal graph for a passive house. If we probably zoomed out Cameron over 2 years, it would actually look a little bit more flatter, wouldn't it? From our perspective.
Yeah, well, you've got an extreme week there where you're hitting, what, mid-40s, is that, on those first 3 days?
We hit 40, 42 and 40, 42 and a half, looks like, outside. And we're sitting.
Worth remembering you had the AC on, though, indoors, didn't you?
Yeah, but so did everyone else. But you can see we're not moving too much across the day. I only had it on from maybe when it started to hit more of our western windows in the afternoon. So around, so probably from lunchtime onwards, we'd put it on, and only on one fan speed.
Nonetheless, it's not a true reflection of the performance of the building envelope when the AC is on.
There's a few things I found when living in a passive house. I don't know whether it's been just a humid summer, but I found that it's been a bit more humid inside than I maybe thought. The biggest tip I can give anyone is don't go buy a thick doona cover because you do sleep a bit warm. I've really struggled to get my bedroom really under 23.5 degrees. It can get up to 24. Probably would have designed the aircon system a little bit differently. They've got ceiling fans in there, so you have to have ceiling fans in there in your bedrooms, non-negotiable. I think you actually need to now, don't you, Cam, from memory in PHPP? No. Definitely need it, but yeah, I found that you do sleep a little bit warmer. I haven't done a winter yet, so I think that it's going to be really interesting to see what happens in winter and how we actually survive that, because that typically you I've sat with the wood fire or the gas heater on and it's either too hot and you turn off and it's too cold. So super excited to get into a winter there. You guys have questions? Anything you want to know from you guys?
Probably worth emphasising, Matt, that your bedrooms here are on the first floor. So the first floor is going to remain warmer than the ground floor.
No, that's on the ground. My bedroom's master bed's on the ground floor.
Oh, is it? Okay, sorry. Oh, your daughter's bedroom's up on the first, yeah?
Yeah, not yet. Hopefully soon.
Okay.
So, yeah, get her out of there. But look, there are 3 people in there and a dog. So we are generating a little bit of heat, I would say. But yeah, it's still extremely comfortable. Any details you want to know more on? I'm also conscious on time with everyone.
What about acoustics, Matt? Talk about, you hear people walking past on the street, cars go by?
I don't even know what happens outside. I actually have zero idea. Unless before I just it was a bit warm. I know I looked at my phone. It said it was 15 degrees outside. So I was like, I'm going to see if I can sort of vent it and see how that sort of plays with some cross flow ventilation. I'm just learning how to use the house. I opened a window and it was pouring. Then I looked at the glass. I could see the rain, but I had no idea. Zero idea it was raining outside. Some people might like hearing the rain, but at least I can open my windows. I've got a choice if I want to hear it. I listened to a TED talk a few weeks ago. It was really interesting where it was a guy who talks about just listening for quiet and just laying down and just listening to what's around you. And if you just be completely quiet. I actually did it for 2 minutes. It was too much because I couldn't hear a thing. And I was really, really, really trying to listen to a plane going over we're sort of under a flight path a little bit, car beeping its horn or something. A bird, couldn't hear a thing. And I was literally actively listening to try and hear something. So that might describe the acoustics. Originally, I had issues with my inverter, which is in that area. I don't think maybe because it wasn't on
You
boost.
couldn't
Maybe
hear
if I
that
took
Swiss
boost, I
filter
might have been
thing
able to hear
going
something
buzzing away.
potentially. But I also wasn't near an exhaust. And I can hear the exhaust at times if we do press the boost in certain areas, but I don't really care. It's better than hearing the from a big aircon. But yeah, acoustics is, I know, Justin, you live in a passive house. Like, I do feel the acoustics are pretty good.
Oh, yeah, they're exceptional. I can't hear anything outside either. People turn up, or sometimes the diesel generator might kick in, which is only behind the workshop in the middle of winter because we're off grid. We have a diesel generator that might come on in the afternoon if it's been overcast for a day or two, and we can't hear it. We sort of go, oh, is the generator on? I don't know, because we normally go and put the dishwasher on if it is. So, the wind, it's blowing a gale, we're on top. It's reduced heavily.
Yeah, the one thing I want to know, like I've considered speaking to Joel, Cam, about getting, because I have found it quite humid, and I know we had a conversation whether you need an ERV or HIV in Melbourne, and from my understanding, it's just changing the core over. Is that correct? Yeah, like I wonder what the cost of just getting a core change for this summer period, because I have found it's been quite humid in here. I've checked outside, it gets up to 80, 90%, but I've struggled some days to get it under 70. Mm.
So it has been relatively humid this summer in Melbourne by Melbourne standards, I think, for those of us who live here. Bear in mind also, as I think I might have mentioned to you, that a year or so after you're building it in, your materials are still stabilising in their moisture content. So any pre-existing plasterboard, the ply, the timber, reaching its equal. And so, and particularly that the infill slab. So there'd be thousands of litres that were in that slab, some of which have been bound up, some of
I
which
wonder
are
if that's
still
got anything to do with my cracking of my
to
slab
come
or
out.
like that. I wonder if that's got something to do with it.
It's not
Justin,
unusual in the
don't
first
laugh.
year.
You've got your window at your house, and this is my
marginally
window at my
higher
house.
because of those wet building
Now.
materials.
It's Cam's got his airtightness. We all have our thing. There was another thing I was going to say. I've also gone against Cam's advice, and I have a downdraft range hood. They're really good to cook with. Can't complain. They're great. Cam might argue the P. But again, we need to. It all comes down to the user and how you use it. Like, I open all my windows, and the only time I really, really set it off, like I've set it off once or twice, like through the roof, is when I fry dumplings. Every time I fry dumplings, like cooking a steak, I find that because I've got so much control on the induction cooktop, they don't burn things as much. But when I do want to fry stuff, I do see it spike. But how much would it spike compare if I had a standard cooktop as well? I don't know, and extracting outside. That's probably the other thing.
Just to be clear to the listeners, we're talking a downdraft range hood that's also recirculating.
Yeah.
So you can downdraft and then externally vent. So there's two things you shouldn't do with range hoods. One is downdraft and one is recirc. You've done both.
I think I agree, Cam, and I disagree with Matt totally.
I disagree with you. It just looks better.
Experience, and since I've put in all the sensors, Cam, I've been monitoring the P2.5s because I actually have gas as well because we're off grid, so induction is just not an option. And I have been monitoring it. The other night I did a stir fry for the kids. Got a round wok, great, love it. But I know that it smokes, and it was up to about 1,000.
Yeah, I've hit 1,000. I was like, "Oh, Cam's going to kill me."
Whoa, it was up and down pretty quickly, but it's like, wow, that is really, really bad. But it's just like smoke. It doesn't clear. I'm actually thinking about externally ducting my range hood retrofit because I can do it. I'm actually going to do it.
Yeah, definitely do it. I just hate the look of it. It just ruined the interior design that they cooked a range hood. So we went that way. Yeah, but where I placed it, I had no choice. Like if I had my time again, I would have thought through it more. That's definitely something that I would have thought through. The other thing I definitely would consider again is, and it wouldn't have changed anything in performance, like it probably would have been wasting money externally insulating. I would have looked into that. But just given the constraints I had on the building, there's something out. Now, I would have put and Cam will hate me here, in my bare bathroom downstairs, it's kind of, there's no natural light, and I probably would have put a skylight, given it's it's covered by south wall, just to vent some of that heat that might be in that bedroom. I potentially would have put a skylight in there just to give it a little bit of light, but also open up to just allow some purging. Cam, are you willing to talk about how important getting not calling it a passive house before it's a passive house?
Yeah, okay. So,
Justin, you're going to love this,
just
and Jess.
One of the long running tirades I have, I guess, is just with what house. And in my world, a passive house is a building that's been through a quality assurance process. It's been reviewed and it's been certified as such. That's the benefit of passive house. It's the review process itself. And so it's not a passive house until it's been through that review, both pre-construction and post-construction. And in Matt's case, we did the pre-construction. We had a letter from the certifier saying that if this building is built in accordance with what you've provided to me, I agree this will be a pass. It was the tick. We did everything right pre-construction. Went through construction, a couple of little changes, none substantial. The certifier identified an error I'd made in the PHPP. And that could have gone either way. It could have improved the heating demand, which is the critical case for us, or it could have
I was
made
at
it worse.
14 kilowatt hours, just to give you guys context as well.
So
15s, they had a small amount of margin, but not a lot. And so conceivably, post-construction, we could have gone up above the threshold and therefore not been able to certify as is.
what was the error, Cam? If you don't mind me
It was a
asking.
reference to there was just one of those classic Excel errors where I was on the window sheet, I was referencing to a wrong wall. I'd cut and pasted somewhere at some point in history.
Post
wrong.
letter.
No, the letter was approved.
Oh, so it wasn't picked up.
No, we didn't pick it up in that pre-construction review.
That would have been a sickening day. I wouldn't have liked that.
It would have been a sickening day, but as it turned out, by fixing it, the heating demand actually went down.
We went from 14 to 9.
I agree, David. There's a comment here saying, so Cam is human. Cam makes mistakes too.
Oh, absolutely. And I think this is what I keep saying. For those of us that are passive house consultants and PHPPs, I'm sure all of us will have that spreadsheet back from the certifier, like 100 plus of them. And I've never, on that first review, had all greens. Never, ever. And I don't think any of us ever will.
And you would. You would be the first. If there's anyone, it's going to be you, Cam.
It's probably not going to happen. And so that review in finding those areas is really, really critical. Many of them are immaterial and don't matter. But this particular one,
until you pass your blower door test, because that's another.
That's easy. That's easy.
Not always.
Nah, I've never had a problem
For
with that.
you on this project, maybe, but not always.
Nah, I like it. Like I think I have a personal opinion that we overcomplicate airtightness. I think there's enough information, and whilst I've joked with Cam, ultimately the reason why people like myself and Hamish and Dylan were able to get so airtight is we've learned off those before us who literally had to work it out themselves. We have so much information there now that to get airtight. So especially I will say on a new build, I'll clarify on that. If I can get my house airtight with some absolutely crazy junctions, it would I still don't know how we got there. We had to use the Viscon spray a few times, Justin, even though we had starter strips and everything, like we still had to use it to get in some spots. You should be on a new build be able to get it. A renovation, yeah, you've got some complexities that you got to deal with. I think when you ended up 0.6, I can't remember, 0.2624. Actually, funnily enough, it was the first time ever Drew's done a lot of tests that he's inside it, his pressurization and depressurization were the exact same number. He's never had that before. They were identical. That was the first time he'd ever had it, he said. Have you had that, Justin, or not?
Never.
Never?
No.
I don't know. Yeah, I see. Mine were in and out the same.
I do find on a passive house though, in a typical house when you do a blower door test, depressurization is usually higher. Pressurization is usually higher. But on a passive house, I found the opposite. Depressurization is usually higher. I haven't quite figured out why that is yet.
I think because we're sucking the tilt and
Windows.
turns open,
windows.
maybe.
Yeah, that's what I figured. That's
Maybe.
what I figured.
I don't know if it's got something to do with the ply and the adhero, potentially.
Maybe. Yeah, just being so stable, do you mean?
Yeah, and we also, that's a good point with that. We actually just by chance had Harley's team come out a day before and tweak everything to tighten them.
Yeah,
So
yeah, that's
after
so
we moved
important
in.
for anyone who does a blower door test on an airtight project, and you have a target that you have to hit. Make sure you've got your window people there on the day.
Oh no, you don't need that. You just got to make sure you can go around on a standard day if it's a bit windy and run your back of your hand against those windows, and you will feel of a bit of a wind outside if they're leaking or not. You don't even need a blower door test to be running.
Yeah. We've just
and-
found that sometimes the window adjustments can make a real difference.
And also if you're testing, don't test if there's a breath of wind outside. It's got to be dead, absolutely dead still. So, you guys have any other questions? I'm all conscious families you want to get to, and I know Justin's, he just messaged me that maths starts soon, so he's pretty keen to get on the couch and watch that.
There is one more question here, Matt. There is a question here from Emil. How did you drain your walls on the boundary?
I've got brick veneer. So they went through weep holes. Bit confused what the question would be.
What were
To the
your
neighbour.
Yeah, what were your
Yeah,
setbacks?
well, on my boundary. I'm literally on the boundary.
So where did the water go? You got weep holes, but where does the water go from the weep holes?
Next door.
Okay.
That's not my problem. No, but I'm on a P class site. Actually, interesting story. So when we were digging the underground rainwater tank at the start, it was 5,000 litres. I was playing with the soil. I was like, something's not right here. They classified it as H1, and I was like, so I called Yasha. I'm like, hey, this is weird, not feeling right. He's like, Matt, you're fine. And then my team are like, stop stressing. It's your own house. Like, you do not need to worry about this. So I then was like, no, I do not feel comfortable with this. I'm going to call the soil testing guys. I called them. They went into liquidation. They're being sued on a number of cases. I ended up finding out. So I called the other soil engineer that we constantly work with now, and he came out and he classified as H2. And he's like, if you built this to what it was, it would have, the house would have shrunk. It would have sunk. So we had to add in, I think, 32 board piers across the whole project to comply with the new soil test, because it wasn't compliant originally. So I'm pretty deep, and I'm into basalt. So we had to core drill about 200 million into each board pier into the rock as well. So we ain't going anywhere. So Emil's also written more so the ventilation being a firewall, because the brick is a brick veneer, is a cavity from memory 40 mil between the back side of the brick and the start of the adhero. We've got 40 mil ventilation in there, and I think we can assume, Cam, from when you've run your numbers before, there's about between 1 and 5 air exchange for a brick veneer.
And that's at ambient pressure, not at 50 pascals. And we're talking about air changes. That's at normal air pressure. So it's not very much.
Yeah, and look, the issue, there's not. But look how much water is getting in there and draining out. Is there ever going to be enough moisture that runs down that wall and going to move foundations? Probably not. Never. Like it should just evaporate within that space a lot of the time. Anyway, thanks for all coming. Next month will come out soon. I think next month we got Cam going deep into OSB versus plywood. Is that correct? Or have I just made that up?
That's correct.
Cool. So yeah, this will be on YouTube in about 4 weeks, I think. We'll just get it edited and cleaned up. But thank you all for coming. Turn this off.
Thank you.